Good morning, my YouTube viewers. It is Crystal here. I'm doing another video for you for a Kaggle competition, and this is for Season 6, Episode 6 of the Kaggle Playground competitions. And this is the second time I made the video because I did enter the competition the first time, and when I was making the video, I realized that I had made a mistake. I had used the wrong kind of encoder. I had used a label encoder instead of an ordinal encoder. And so I decided to redo the code because I thought, well, I can't use a label encoder when I didn't encode the label. So I had to go back and redo it, and then I deleted the first video that I made because I didn't want the label encoder to be in that video because I hadn't used the label encoder. So this is the second version of this competition, and it's the second video that I've made. So basically the competition question is the problem statement is you have to predict on a stellar class, and you've got three classes, one being a galaxy, one being QSR, I'm not sure what a QSR is, maybe it's a quasar, I'm not sure, and then one being a star. So you have three different classes, and then you have to predict on that stellar class. The only thing that I had to work on was the data set that was provided by Kaggle, and I didn't know that much about it, but I went ahead and did the competition anyway. So we have predicted on a stellar class, and then now what we're going to do in order to write the program, we're going to import the libraries that we're going to need to use for this program. So we're going to import NumPy as NP to perform numerical computations. We're going to import Pandas as PD to process the data. We're going to import OS to go into the operating system. We're going to import Sklearn to provide machine learning functionality. We're going to import matplotlib.pyplot as PLT, and we're going to import Seaborn as SNS to visualize the data. Although I don't think I used Seaborn, I think I was using just matplotlib, because I have found that whenever I use Sklearn, some of the code is deprecated, and they don't really give you code to replace it, and so I just tend to use matplotlib when I can. Okay, so after we have imported our libraries, then what we're going to do is we're going to retrieve the files using the program, and we're going to use OS to actually retrieve the files. We're going to get 3 CSV files that are loaded in Kaggle's directory, being train, test, and sample submission. So after we have retrieved our 3 files, what we're going to do is we're going to convert the files, the CSV files, into data frames. But what we want to do is we want to use Pandas to set the screen up so that you can see all of the columns of data. So you type setpd.setOptions brackets display.maxColumns comma none, and what that does is that sets the screen up so you can see all of the columns of data. And then we use Pandas to convert the CSV files to data frames. And we have 3 data frames, being train, test, and submission. So this is the train data frame that you can see. It's got 12 columns of data. The last column of data is your class. The last 3 columns of data are object columns. And your class is your target. We check the info to show you information about all of the columns of data. Column number 0, which is ID, is an integer column, and so really you don't need the ID column. The reason why is because Pandas automatically indexes every row of data, so you don't need the ID column because every row of data is indexed. The rest of the columns are floats, which is another numerical column, and the last 3 columns of data are objects, with the final column of data, class, being the target. We check for any null values. We don't have any null values. And then we check test. Test is the same format as train, except that you do not have the final class column, because that is what you're going to be projecting on. We check the format of test, and the format of test is the same as the format of train, except that you don't have the class column, because that's what you're predicting on. We check for null values. We don't have any null values. And then we check the submission. This is what Kaggle wants to see when you submit your data. Okay, so what we're going to do is we're going to drop the ID column. The reason why we're going to drop the ID column is because Pandas automatically indexes every row of data, so you don't need to drop a column. So if you drop the column, you have less columns of data for the machine to analyze, and so that's a good thing. So now what we're going to do is we're going to analyze the trained data frame, and we're going to convert all of the columns of data into a histogram. And there's more that you could do as well. If you wanted to do more, you could like select the max, the min, and the median to give you the max, min, and median. So like if you were going to be doing a proper data analysis, then what you might do is you might do a summary or a describe. There's other functions that you can do that would give you information about the entire data frame to give you the maximum, the minimum, the median, and the count and things like that, but I didn't use it in this video. I think it's if you do describe, I think it's train.describe that you can do that, but I haven't done it on this occasion. I just created histograms. But if you're doing a proper analysis, like an analytical, you want to find out the maximum values, the minimum values, the means and the medians, you can do that. And I think it's the describe method that you can use to do that, although it wasn't done in this one. So we create a histogram of alpha, and so this is our alpha. We create a histogram of delta. You see, this is our delta. Create a histogram of U. You can see this is our U. We create a histogram of G. You can see this is our G. We create a histogram of R. This is our R. We create a histogram of I. This is our I. We create a histogram of Z. We create a histogram of redshift. We create a histogram of spectral type. We create a histogram of galaxy population, either red sequence or blue cloud. Don't know what that is, but hey ho. And then we're going to create a histogram of the class, and your class is your target. And you have 3 classes, being galaxy, QSO, and star. I'm not sure what QSO is. Maybe it's a quasar. I'm not sure. But if you, as I said earlier, if you wanted to know the statistics of all of the columns of data, then you could do train dot, and I believe it's describe, and that would give you the statistics. It would give you the maximum, the minimum, the mean, the median, and the count, and that would give you some good information as well, which perhaps I should have put it in this video as well, but I didn't. It was an oversight on my part. It does take a minimum of 10 minutes to train the data, so obviously it's not something that I'm going to say, oh, I'm going to go rush and do it. But if you want to know that information, I think it's the describe function, and that will give you that information. And so now what we're going to do, we're going to encode the object features, because there are 2 columns of data that are categorical or object, 2 columns of data that are object, and so we need to encode those because Sklearn does not have any models that will handle categorical features. So you have to take these object columns, which are categorical features, and you have to convert them to numbers. So we're going to use the ordinal encoder in Sklearn. So we don't have any unknown values, but if there were unknown values, you would say use encoded values, and then the unknown value equals 5. So for call and test, I use test because test doesn't have the final column being the class column. If train call.dtype equals object, train call equals encoder.fit transform, train call.values.reshape -1, 1, test call equals encoder.transform, test call.values.reshape -1, 1, and then we check train info and test info, and you can see that now in train all of the columns of data except for the class are numeric, and in test all of the columns of data are numeric. So now what we're going to do is we're going to define our x and our y variables. So your y is going to be the class column of data in the train data frame. So y equals train.pop class, and then x is the remainder of train, because what pop does is pops out the column that you're asking it to pop out, and then it leaves the rest of the data frame intact. So x is the rest of train, and x test equals test. You're going to use train test split in Sklearn to split the data set into training and validation sets. And so you're going to have a test size of 20% and a train size of 80%, random state equals 42, shuffle equals true, stratify equals y, and then you check the shapes of x train, y train, x val, y train, y val, and x test, and you can see that the x data frames have 10 columns of data, and the y data frames have only 1 column of data. So we're going to define the model. We're going to use Sklearn's Extra Trees Classifier. I just gave it in estimators of 1,000. The more estimators you have, the longer it's going to take to actually train the data. Max features is square root. Class weight is balanced because there was a class imbalance when we analyzed the target, and because of that class imbalance, I said class weight equals balance. Min samples leap equals 5. You can make that lower, but the lower you make it, the longer the training time is going to be. And random state equals 42. We're going to fit the model with x train, y train, and we're going to make predictions on x val, and then we're going to check the accuracy. So accuracy equals balance accuracy score, brackets y val, y pred, and we get a 95% accuracy. And then so now what we do is we use Matplotlib to create a histogram of y pred. And this is the history of the prediction of the validation set, and so it's similar to the train, so that's good. Now we're going to predict on the test set. So pred equals model.predict brackets x test, and then we create a histogram of the prediction, and it's similar to the train set, so that's good. And then what we do is we prepare our data for submission. So submission class equals pred. We convert the submission to a CSV file with index equals false, and then we convert that CSV file back into a data frame, and then you can print submission. This is what we're going to be submitting to Kaggle. And when we have submitted our work to Kaggle, I got a 95% accuracy, which I think is okay. I think it's okay. And then, but what happens is that the highest accuracy was 97%. So I got pretty much 2 percentile less than the highest percentage in the Kaggle competition, which if I wanted to, I could try different models to get up to 97, but I think I'm going to leave it as it is at 95% because I have a lot to do, and this is the second time I've run this up, and this is my second video, but you won't see the first video because I deleted it. So that's it for this program. You've seen Kaggle competition Season 6, Episode 6, where you predict on a stellar class. I hope that you got something out of this video, and I will be communicating with you on another Kaggle competition next month.